Okay. Now this is a tricky one. Okay, I got tricked because I thought wrong. I thought what did I thought wrong? Okay, so initially I thought where I shaded red over here, it will have the highest what? First moment of area. Okay, but by looking at it, I was wrong. This is equal to 14.4. I will write down here, cannot ignore the negative. Okay, this is the first time I've seen this. Okay, and then when I do this, when I take the Q15 and Q24, the value is equal to what? 10.8, which is smaller. Okay, so you have to use the biggest what? Q. Okay, so we have to use the biggest Q over here, and then we calculate our forces, and then we calculate our radius. If we were to use a smaller Q value, okay, then the forces will drop. When the forces drop, unfortunately, what will happen is the radius of the boat will become smaller. Okay, so this is a good question. Again, I think the most important thing is how to consider, okay, the first moment of area. These are critical. Again, the rules still stand. The first moment of area, the shear flow will distribute through the entire member first. Okay, then it will transmit onto the boat. Okay, right. So that is question 8. Okay. The next one is question 7, homework 8. Homework 8. Oh, sorry. Question 7, homework 8. Nazim, is that the one you want me to do?
Yeah.
So it's not this question you want me to do then?
I also like this question, so it's fine.
Okay, no one stop me. Okay. Okay, so you have this question over here. Okay. I'm not going to take a break. Okay, we go all the way. If you need a break, you can so I can have maximum time with you. Okay, so next is homework 8. And we're going to do question 7. Okay. Wait, question 7, homework 8. Okay. So we are given a steel pipe. Okay. And the steel pipe has a outer and internal diameter. So we have to determine the factor of safety against yielding of the material at point A, okay, based on the maximum shear stress. So the first thing that we have to look at is, so if a question like this comes out, I will give you the stress yield is equal to what? Is equal to 250. Okay, 250 times 10 to the power 6 Pascal. Okay. Then if we look at the maximum shear stress criteria, right? If we look at the maximum shear stress, is stress yield divided by 2. So the maximum shear stress allowable is 1 to 5. Okay. And this is from the yield stress is from the materials handbook, and is again from testing, right? Okay. And we know all this. This is uni axial test, one direction. Okay. So from here, I'm going to call this X. I'm going to call this Y. I'm going to call this Z. Okay. So the first thing, I mean, they say it's at point A, and there's no indication where at point A. Okay. It's okay. We do what we can determine first. Okay. So the first thing we have is we're going to find our, look at our member. So we are going to look at our XY plane first. Okay. And then moment about, or rotation about Z. So if I'm going to sketch this out, right? So we have a load down here coming at 900 Newton. And I have a load down here that's going up by 900 Newton. Okay. And then we know the failure is at point A. Okay, so I don't know point A, is it in the wall or point A? I think the point A, yeah, point A is not in the wall. It's somewhere around here, point A. Okay. So if we were to sketch the shear flow diagram, or this is our X, the shear flow diagram will look like this. And this is your 900. At point A, we realize that the shear flow will be equal to 0. Okay. And you can do this by doing like positive is going up. Okay. By at point A will be equal to 900 minus by 900, and this is equal to what? 0. Okay. If not, you can also do by what I've shown you. Okay. Then we look at moment about Z. Okay. So we look at moment about Z. So moment about Z, right? You can call this anticlockwise to be positive. moment bulk Z at point A will be equal to, right? So it's equal to 900 multiplied by 0.15. So it's going in the anti-clockwise direction, minus 900 multiplied by 0.15 plus by 900 multiplied by 0.25. Okay. So 900 plus by 900. So you have a moment of 90 Newton meter. Let me do it again. 900 minus 900 multiplied by 1 plus 900 multiplied by 25. Yeah. And you realize that this direction is correct because we assume that over here, this is positive. So this is your moment bulk Z. This is where you have your compression. And this is where you have your tensile. Okay. But it's a rod, it's a shaft. Okay. So at point A, you will see maximum compression at the top, maximum tensile at the bottom. Right? So based on maximum shear stress criteria, maximum tensile, maximum compression is the same. So it does not matter whether you take from the top or if you were to take from the bottom. Okay. Then next, we find the torque. Okay. So the force is 900, right? So you have two forces, right? So the torque, and it's the same direction, right? So the torque about the x-axis is equal to twice times by 900 multiplied by 0.2, right? Why twice? You have 900 over here, you have 900 over here, and you have your radius over here. I don't like the solution manual, okay? Because the solution manual writes down 900 times 0.4. I hate that, okay? So, torque is equal to force times by perpendicular distance, okay? So it should be 1800 times by 0.2. So this is confusing, okay? So that's why I'm not a fan of the solution manual. I just use it when I have to use it, okay? Just to check. So we know that this is equal to 2 times by 900 times by 0.2 is equal to 3600 meters or 360 Newton meter. Okay. Now the fact that it's going in a clockwise direction, as you can see, the torque, the x, the solution quite negative does not matter. Okay, really does not matter at all. Okay. So there are two formulas that we need to apply. Okay. So now before I go on, so if I will have to have a shaft down here, if I would have a, right? So based on the transformation, this is a y, z, and rotation x. So remember when I taught you all questions like that, we have element A, element B, element C, and element D, right? And based on this problem that we see down here, if we have element A, B, C, D, right? The shear, which is equal to TR over J, right? Element A will see TR over J. Element B will see TR over J. Element C will see TR over J. Element D will also see TR over J. And if you look at the normal stress, which is equal to mz over izz multiplied by y, right? Element A and C will be equal to 0. Element B will be mz over izz multiplied by y. Element D, or element A will be minus, B will be element D will be positive.